All right, this is the Foundations of Mathematics and Pre-Calculus 10 sample questions for measurement. In this section, I'll walk you through the associated questions. In my opinion, I find measurement to be the questions that give students a little bit more difficulty than others. You'll see the first one, as per normal, is a question where you can't use your calculator, and of course, you'll see in this question you don't need a calculator for anyways. Which of the following examples is the best reference? Remember, reference are what we use to estimate various quantities for 1 millimeter. So obviously 1 millimeter is very small. The diameter of a penny, would that be a good reference for 1 millimeter? Well, remember, they're not talking about the thickness of a penny, the diameter of a penny, so my guess is probably not so much. The thickness of a fingernail. Thickness of a fingernail, if you look at your fingernail, not very thick. I'm thinking that's probably a good answer. Let's just check the other ones to be sure. The length of a $5 bill, obviously that's way longer than a millimeter. The distance from the floor to a doorknob, obviously that's a greater distance as well, and so we're pretty confident we can pick B for this one. Number 2. Which expression could be used to calculate the surface area of the right square base pyramid with a base length of 10 and a height of 12? So they're saying the base length is 10, so that would mean this dimension right here is 10, and this dimension here is 10. Well, of course, all of them around are 10. We also know the height, so the height coming from top to bottom right here is going to be 12, like so. And so since we're looking for the surface area of this thing, you should note that we have two different figures. We have the square, they tell you it's a square at the bottom. So right away, if you take a look at that, if I look at these equations, I have surface area is equal to 2, so they're multiplying them all by 2 for some reason. We'll have to determine why that is. Then we have 10 times 12, and then we have plus 10 squared. Well, the squared part is the part that is the base. All right, and so right away I know what the base is going to be 10 times 10, so right away using process of elimination you can get rid of B and D like so. Oops, kind of missed the B there. So we only have A and C left, and so we need to determine then how we figure out the other part. We already have the base, now we got to deal with these triangles. Now if you recall, to find the area of a triangle, you need to know the base. We already know the base is 10, and we need to know the height of the triangle. The part that students are going to confuse is they're going to think that if you can imagine this height right here is different than the height coming right down from the middle. And so if I draw you this triangle like so, where that would be a right angle and this height is 12, this is the height that they're looking for, the triangle. So that's the part that we need to get. Well, we know the height of the overall figure is 12. We know that the entire distance across is 10, so that means this distance must be 5. And so then if we use Pythagoras, we should be able to find out the height of that triangle, which I'll call h. So we have h squared is equal to 12 squared plus 5 squared. And when we solve this, we have 12 squared is 144 plus 25, and lo and behold, that actually gives you a nice perfect square number, 169. When you take the square root of it, you get the height is equal to 13. Now if you think of this, let's first worry about the area of one triangle. The area of one triangle is base times height divided by 2. Well, we figured out the base is 10, the height of that triangle is 13, and we got to divide by 2. But let's back up the bus for a second. That's just one triangle. How many of these triangles do we actually have? Well, we have 4 going all the way around. So really what we're going to do is we're going to take this answer and multiply it by 4. And if you see, this will simplify such that that 2 and this 4 will reduce to be a 2. And that's how they have these numbers on the side here, which you see is 2 times 10 times 13, which is no different than what we have right here. And so again, we're confident our answer is C in this case. Number 3, which of the following expressions represent the volume of the cylinder below? With any figure, you have to find the area of the base, and then we just multiply by the height. So in this case, we have volume is equal to the area of a circle. So we have pi r squared. You might need to go to your formula sheet to recall that. And then times the height. So I'm going to substitute in the appropriate terms here. This may kind of sketch you out a little bit because we have algebra, but it's not the end of the world. So we have pi, and then we figure out what our radius is here, and then we'll square it. Well, we know that the diameter is equal to 2x plus 4. So if we want to find the radius, we can just take that and divide it in half. So in that case, it'll be x plus 2. So I substitute x plus 2 in for the radius, and we multiply by the height. The height in this case is 3x minus 1. And from there, it's just a matter of us using the distributive property and gathering our like terms. So we have pi, and I'm going to write this like so, as x plus 2 all multiplied by x plus 2. And you'll notice that in the answer key here, they've or the answers they left pi on its own. So I'm going to do the same thing. When I distribute out the first two terms, or sometimes your teacher may call it FOIL, I have x times x is x squared. 2 times x and then another x times 2 gives you a total of 4x, and then 2 times 2 is 4. And so the last thing I have to do to finish this question is I have to now use the distributive property between these two brackets. So I will multiply the first two terms. X squared times 3x is 3x cubed. X squared times the last term there is negative x squared. 4x times 3x is 12x squared. 4x times negative 1 is negative 4x. And then the last ones here, we have 4 and 3x is 12x. And lastly, negative 1 and the 4 gives you negative 4. And finally here, gathering my like terms, how many x cubes do I have? Just that one term, the 3x cubed. The x squareds, I have both of them sitting right there, and when you add them together, we have 11x squared. And the negative 4x and the 12x gives you 8x. And lastly, we have minus 4. And so you will see that that matches exactly C. Number 4, determine the measure of angle QPR. That is the problem right there. It's just understanding what that notation means. A lot of students have no idea what that's asking. In triangles, often we'll have figures like this where if I had just asked you folks which angle P was, we wouldn't know necessarily. You could say that angle P is this angle right there. You could say it's that angle right here, or you could say it's the entire thing if I just said find me angle P. And so as a result, what we do is we use notation like so. And so I'll just call this point, let's call it S down here. You could have QPS would be that angle. You could have RPS would be this angle. And if you want the whole angle, which is what we have in this case, from Q to P to R, they're asking for that whole angle like so. All right. So it's up to you what you want to do with this question first. Of course, because we're looking with an angle here, or trying to find an angle, I should say, we're going to use some trigonometry. So I'll attack this part of the angle first, okay? And so we'll call it x, let's say. So in terms of x right there, you'll notice that this right angle triangle we have the opposite side being 10 and the adjacent being 6. The ratio that combines opposite and adjacent is tangent, so I will take the tangent of x is equal to my opposite side 10 over 6. And when you take the tangent inverse to get x by itself of 10 over 6, you will see that to the nearest degree you end up getting 59 degrees. Okay. Another big note is make sure your calculator is in degree mode. That would be not so good if you took the entire provincial exam in the wrong mode. All right. If you're one of my students, I'll be there though to check it for you. So we now know that that part of the angle is 59 degrees, but of course that's not the whole thing. So just that part's equal to 59. Now let's come and do this other angle. I'm going to call this part right here, we'll call it y. So in that case, notice that in terms of y, we have the adjacent side 6 and we have the hypotenuse 18. So that would be ka. So the cosine of y is equal to your adjacent 6 over 18. And when you isolate y, you have the cosine inverse now of 6 over 18. And when we round that to nearest degree, we get 70, well actually I won't round to nearest degree, you get 70.5 degrees. When you add these two up, you'll see that you get approximately, I think it's 129.5 degrees. And of course this is the only one that's anywhere close. There we go. Number 5 is kind of a strange one. It almost reminds me of a question that you guys might have had way back in grade 8, dealing with nets. You have to figure out which one of the 4 diagrams that I have on here would be appropriate to the one that we have. My suggestion is, remember that these sides, the one with the smiley face, the dollar sign, and the little arrow, they have to touch. So I'm thinking that these sides, the side of the smiley face and the dollar sign, are the longer ones. So I'm going to put a little bit of maybe a line that goes like so. And then I'm going to put a line that goes here. So we know that the happy face has to touch everything. Well, that kind of looks like that's happening in A. So I'm actually pretty confident the answer is going to be A here. But let's just go in and disprove the other ones. You'll notice that the happy face here is not touching the other side. So like it's impossible, no matter how you orient this, to have the happy face touch the dollar sign right there. When you wrap it all around, the happy face will touch that part right there, but it's not going to touch the dollar sign, so we're pretty sure we can eliminate B. Let's go down to C. C, again, here we have this this problem right here. So if you can imagine wrapping up this figure, these two objects won't match C, so we have a problem. And this case right here, remember how the arrow, if we go back up to the top, and the happy face were able to touch? Well, if you imagine this figure being wrapped around, that being wrapped around, and this being wrapped around, it's impossible for those to ever touch. And we can see that all three of these guys, just like the figure I have, touch like so. Okay, so the answer for number 5, of course, is A. All right, number 6. Raj was asked to make a cylindrical tank with a lateral surface area of 2,622 meters squared and a height of 23 meters. Which net diagram below would be correct for this cylinder? So what I would start with first here is you'll notice that these rectangles that we have in here, 2 of them are the same and 2 of them are different. So why don't we go and eliminate 2 of them right away, and then we'll look and figure out how those circles should be situated. So what I know is that if you recall, you have a cylinder, let's say it looks like so. The part that goes around here, or this part like so that I'm coloring in, that is a rectangle. And so if you recall, once we kind of pull that rectangle apart like so, you have the circumference on the top and then you have the height right here. So we know that that rectangle, they tell you the area of the rectangle, so area of the rectangle is equal to 2,622. But to calculate that, I take the circumference and I multiply that by the height. Well, that means that in this case I'm going to have the circumference, which is 2 pi r, times the height. Well, we know a little bit about this, right? We know that the height is equal to 23, so I have 2 pi r times 23. So if we divide both sides by 23 right here, we'll have 2 pi r is equal to 114. All right. So what that means is that we have our 2 pi r, the circumference of this thing, is equal to 114. So that means that we can eliminate 2 of these. We can eliminate A and C like so. Now, from this stage, we have to figure out what's going on with these circles, which one of these circles would make sense. Well, if you take a look, imagine B right here. Imagine you unraveled this circle right there. Would that circle match up with this being the circumference? I hope you see that they won't. Neither of those will. But if you were to unravel this circle right here, that circle I just wrote will be the same as this length right there. Same on this side and same on this side. So your solution is D. Number 7, calculate the volume of the right cone below. So, interesting question right here. They've given you the slant height, so that's the 25, and they've given you this random angle right here. They've told you that angle, I suppose, is 20 degrees. So, in order to find the volume of any figure, if you recall, it's the area of the base times the height. When you have a cone like this, it's the area of the base times 1/3 and then the height. So I'm going to write that first. We have volume is equal to 1/3, and this is in your formula sheet. 1/3 the area of the base, and then we times this by the height. Okay, so in this case right now, we don't really know any of that, because remember the slant height, which is this 25, is different than the actual height right there. Okay, so we have ourselves a little bit of work. But you'll notice if I kind of blow out this triangle over here, we have this triangle like so, and we know that's 20 degrees, and they told you the slant is 25, so we know that that is 25. Well, these, if I call this, I guess in this case this would be r for radius and this would be my height, those are going to be very important. So why don't we go and find what r and h are? Notice that that's a 90-degree angle. Well, we can find r using trigonometry. So in this case, from the 20 degrees, that being your reference angle, opposite of r, that would be your opposite side, and you have your hypotenuse. So we would do something like so. We'd say the sine of 20 degrees is equal to my opposite side r over 25. In order to isolate for r, you'll multiply both sides by 25, and you have 25, the sine of 20 is equal to r. And if you check this into your calculator, you get that r is equal to approximately 8.55. Okay, so that's important for us. The second thing, maybe I'll just scroll down a hair here, is we need to find the height. And so the height, again, I'm going to use the 20 degree as my reference angle. In this case, though, I'm using cosine because it's my adjacent side. The cosine of 20 degrees is equal to my adjacent, which is, in this case, h over 25. And we multiply both sides by 25 again. You have 25 cos of 20 is equal to h. And we find out that the height is equal to do decimal places, it's 23.49. So now, finally, you can substitute all this jazz in here. So we know that we have 1/3 the area of the base. Remember, the area of the base is a circle, so we have pi. Then we have the radius all squared. So in this case, the radius all squared, actually I don't need to write those brackets, I'll just go pi. The radius we found was the 8.55 all squared. So that's the area of the circle, and now we have to multiply by the height, and I think we just found out that the height was that number right down here at the bottom, which was 23.49. You will put all this into your calculator and multiply everything together, and I believe to approximately one decimal place, so this is approximate, you have the volume equaling 1,798.2, and since we're dealing with volume and we had centimeters, we would be in centimeters cubed. Okay, and so what we do right here is we would then look to see what answer is the closest, and you'll notice that this answer, something looks kind of wrong. Like, why isn't it? Because of course if we rounded this, it would be 1798. Well, what you have to remember, and this is a multiple choice strategy I've kind of given you here, is we've rounded these numbers right here, rounded those numbers there. If this were a written question, so the questions that fall at the end of the test, I would expect you to carry some extra decimals there to make sure that you're good to go. So in this case, I was pretty confident. I looked at these answers, I saw they were all different. That's how we can say that we're happy with B. Number 8, determine the surface area of the solid below. So what do we see here? Well, we have a hemisphere, so it almost looks like an ice cream cone, the top of the ice cream cone, and then we have the cone. So we have to deal with both of these figures. We have half a sphere, of course a hemisphere, so why don't we deal with that first? So I'm going to deal with the hemisphere over here. The hemisphere, if you recall, the surface area of a sphere is 4 pi r squared. And so all we're going to do is we're going to hack that in half. So we have 2 pi r squared. All right. And when we substitute in your radius, of course our diameter is 10, so our radius would be 5. This is one where you can crunch it in your head pretty easily if you wish. 5 squared is 25 times 2 is 50, so you have 50 pi. I'm just going to leave it like that because that's exact for right now. You could put into your calculator to get a decimal. So we know that that part of it is 50 pi. Now we have to deal with the cone. So let's do the cone over here on this side. Okay. The cone for this thing. So they tell you that the entire height is 30. This is a little bit tricky because we know that the diameter of this whole thing. So imagine if this was a full sphere, you would know that that whole thing going all the way down is 10. But because the cone comes right to this stage, we know that that distance is 5. So for what we're worried about, the entire height from here to here is really 25 centimeters. So keep that in mind because that's going to be important. So if we want to find what this slant height is here, okay, because you might recall that to find the lateral area right here, you have, so I'll write maybe the surface area of the cone. Okay, it's just the lateral area of the cone is pi times rs, where s is the slant. So we know that we have pi, we know that the radius is 5, but to find that slant height, we got to do a little bit of work. So I'm going to do that work down here. So I'm going to construct that triangle, similar to what we've already done before in a question earlier. We have something that looks like so. We know that our radius is 5, and we found out that the height, remember this whole height that we had right here is 25. Okay. So now using Pythagoras, we have 5 squared plus 25 squared will be equal to s squared. I'll try to make my s look a little bit different than the 5. When we crunch these numbers, we would have, what's that, 625 is 25 squared, plus 25 is 650. And if we round to, let's do, I don't know, actually we can just leave it like so. Let's just leave it as s is equal to the square root of 650. So that now is my slant. So now if I take that amount and I substitute it into this side for my slant up here, I have the square root of 650. Okay, so if we want the surface area total, it'll be one kind of thing we'll enter into our calculator. We have the cone, and we need to add it to the hemisphere. So I'll just leave cone plus hemisphere. The cone was 5 pi times the square root of 650, and the hemisphere we had was 50 pi. And crunching those numbers, the total surface area to, I think, approximately one decimal place here is 557.6. And so if we round this to the nearest amount right here, you'll see that this works quite nicely. We have our solution being B, okay, 558 roughly. All right, some tough questions, absolutely. Number 9 is one of those ones that should hopefully make you salivate a little bit on a provincial exam. Some of the ones we've done earlier here have taken us, probably upwards of 3 to 5 minutes, where this one shouldn't take more than a couple seconds. Which of the following angles is an angle of depression? So let's talk about angle of depression. Angle of depression kind of works like this. If you are standing here and you're looking straight out at something, the angle that it makes with, let's say, I don't know, you have something sitting over here on the ground, who knows what it is. This angle between this being the horizontal, so that's your line of sight, and your object, that's called the angle of depression. And so you'll see in this case, it's quite obvious that that would end up being C right there. All right. Another angle that you'll see sometimes is they'll talk about the angle of inclination, or sometimes the angle of elevation. That is this angle. It's with the horizontal, but then going up to whatever object you're looking at up there. Okay. Number 10. A cat on the ground is 50 meters away from the base of a pole. An osprey's nest is on the top of the pole, which is 20 meters tall. What is the measure of the angle of inclination from the cat to the osprey's pole? All right, so just a relatively basic trig question we have here. You got to make sure you draw the diagram though well. And so we have something looking like this. I think we have an osprey. It said it's in a top of a pole, so we'll have the pole here. I'm awful at drawing pictures, so I'm just going to write that we have the osprey up here, and we have the cat over here. So a cat on the ground is 50 meters away from the base of the pole, so we have 50 like so. Osprey's nest is at the top of the pole, which is 20 meters tall, 20 like so. What is the measure of the angle of inclination? So remember, we just talked about the angle of inclination. That would be the horizontals right across here, and then looking up at the osprey, we see that angle. I'll call it theta, and we would need to use which ratio here? Well, we have my opposite side, and we have the adjacent side, 50. So that is TOA, or tangent of theta, is equal to my opposite 20 over my adjacent 50. And when you take the tangent inverse of this, right, to get theta by itself, to the nearest degree, you end up getting approximately 21.8 degrees. And when we round it to the nearest degree, as they wanted right here, we have 22 degrees. All right, number 11, calculate the volume of the shape below. You'll notice that this is kind of an interesting composite shape. We have a rectangular prism down on the bottom here, and we have half a cylinder up top. So I'm going to break this into the two shapes that we have here, and then we'll join them up and find the total volume in a second. So we have the volume. I'll draw myself a little bit of a picture so I can denote which one is. That's the volume of the rectangular prism. That's equal to the area of the base, which in this case I'll call 10 times 16. I'll multiply that by the height, which is 25. And let's see here. 10 times 16 is 160. 160 times 25 is 4,000. Okay, so we have 4,000 meters cubed for that volume. Now I'll come over here to the volume of the cylinder. Now remember, the volume of the cylinder, maybe I'll just write the equation first. It's the area of the base, which is pi r squared times the height. But remember, we only have half the base, so I'm going to divide that all by 2. So in this case then, I'll have pi, my radius. That might give people some difficulties. Like, what is that radius there? Well, remember, that radius is also the same going this direction, which would be 8. So we have 8 squared. And then we have the height, which is 25, all divided by 2. And if you crunch those numbers, we get 2,573. And then, of course, when you join those amounts together, sorry, not 2,573, 2,513, little typo on my part. When you join these amounts together, you see that that gives us, what is that, 6,513 meters cubed, which is A. Okay, bravo. Number 12. A wooden block is a square-based prism, as shown below. Given the base area is 50 centimeters squared and the height is 12, what is the surface area? Okay, that's kind of an interesting thing. So given the base area is 50, well, what does that mean? That means that each one of these sides then right here is going to be the square root of 50. Square root of 50, because we know that if you take the square root of 50 times it by the square root of 50, that would give you 50. All right. Now, we need to calculate all these different shapes. So we have a bunch of rectangles, and then the top and bottom are squares. So we have the surface area of this thing is equal to, let's break it down into its various sides right here. So I have the, let's call it, we'll say we have the top, we have the bottom, and we have the 4 sides. Now, in this case, I know that the top and bottom are the same, so I could call this 2 times the top if you want. And we have the 4 sides, and we know that all 4 of those sides are the same. So I'll just write it as 4 sides like so. So if we take the top and bottom, well, remember they said the base area is 50, so we can just write 2 times 50. And we have the 4 sides. Well, the 4 sides are going to be 4 sides times what are the dimensions of those sides? Well, that side as an example would be the square root of 50. And I believe they told you that the height is 12, like so. And so when you crunch those numbers, 2 times 50 is 100. 4 times 12 will be 48 times whatever the square root of 50 is, a little bit more than 7. And when you add all these up to approximately 1 decimal place, we have 439.4 centimeters squared. B. Okay, number 13. One that looks kind of complicated. Which of the following net diagrams represents the figure below? Note not all diagrams are drawn to scale here. So at first this one looks maybe kind of scary to you. You're dealing with a net diagram. Maybe some of you want to jump to conclusions right away. If you kind of go slow and systematically at this question, it can be fairly easy with not really any number crunching in my opinion. What I noticed right here is we have a bunch of, if I kind of scroll down here, a bunch of different rectangular options. So we have the 3 pi, we have the 6, up here we have another 3 pi and a 3. So I'm going to try and narrow down what's going on there with the rectangle right here. So if I deal with this rectangle, they of course are telling me that the height is 3, so that doesn't change. They're telling me that my diameter from here to here is 3. And if you remember, if you want to find the circumference, if we unfolded this, it would make this rectangle. The circumference is at the top, c. Well, what's c equal to? Circumference is either equal to 2 pi r or it's equal to pi times d. So in this case, the circumference would be equal to pi times d, pi times 3, or just 3 pi. So that tells me that I can eliminate b, and I should be able to eliminate d right here. Now, what is the difference between a and d? Well, there's not a huge amount. They both have the same circle, same circle. These parts, of course, are the same, the rectangles. You'll be able to see that the difference is these circles that we have up here. Okay. So at this stage, if we want to figure which one is going to be more reasonable between A and D, you'll notice that those kind of weird Pac-Man looking shapes might be kind of hard to figure it out. The way I look at this question is I kind of see that A looks to be more like an answer that's reasonable, just because this one is so small to have this this side meet up with that side. It doesn't look like it's possible. But then what I do want to note is I want to note that in the question they did say everything's not drawn to scale, so maybe that's not enough information to make that conclusion. So let's go and crunch some numbers just to be careful. So let's concentrate on this little cone right here at the top. So what do I know about this cone? Well, we know that it has a height of 2, so I can write a height like so. We know that the diameter of this whole figure is 3, so this would be 1.5. Let's go and find this slant height just to see what's going on right there. So to find the slant height, I have s squared being the slant is equal to 2 squared plus 1.5 squared. And crunching those numbers, when you add those together, 4 squared and 1.5 squared, that gives you 6.25. And the nice thing is when you take the square root of all that right here and here, it gives you a nice answer. It gives you exactly 2.5. And so what does that mean? Well, that means if you were to unfold this thing, the actual height that you'd have for this, this figure, like so, would end up being 2.5. You'll see that that matches nicely with A. So I think, I don't know if you always want to do this on the provincial exam, but if you had that exact question, you could perhaps look at it, but we've definitely proved it with that. All right, number 14, which prism can be formed by the net below? Note all diagrams this time are drawn to scale. So they're trying to make that quite obvious to you. They have that note twice right here. So we can assume that. So let's take a look. What do we see here? We have obviously some rectangles, and these look like pretty close to an equilateral triangles. Maybe not. Maybe they're just isosceles, I'm guessing, like that. So let's take a look here. So it's kind of hard to show this all in one picture, so maybe I can just do A and B first. Well, what do we see here? Notice that the triangles here are not made with this side like so, and so I think for that reason you can eliminate A, because you'll notice that that's what's happening right there. B, what can we see? Well, this one looks like these triangles, if they're supposed to be drawn to scale, that triangle is obviously not the same size as that one, so that one seems to be problematic. Let's go and deal with C and D. C, if I kind of go bounce back and forth here, I think is the right answer. But let's go and see if we can disprove. Yeah, and actually we can disprove D for the same reason it didn't work with A right there. Because remember, the rectangular size, obviously there's no triangles that look like that one along. Those are too big. So we have C. So that's a little bit of a strange one. I don't know if I've ever heard of that happening in an actual provincial exam, but hey, you never know. number 15. And so this is an example of one of those written questions. So when we have our answer right here, we want to be quite precise. Don't round to the last step. I know that they're only asking to the nearest centimeter, but you have to be careful. The lateral surface area of a cylinder is 1,106. Make sure you remember what lateral surface area means. That means that they only care about the part that I'm making red right there. So that's their lateral surface area right in there. So given that the height is 11, what do they want? They want the radius. So they want the radius from here to here. Well, surface area, if you remember, for just the lateral part of this is really just the surface area of a rectangle. And we know that when you unfold that thing, you have the circumference on the top and you have the height right here. So the surface area, if I actually lasso this and move it over out of the way, we have surface area is equal to the circumference times the height. So in this case, we have 2 pi r times the height. We know what the surface area is. They told you it's 1106, and that's going to be equal to, that's going to be equal to 2 times pi times the radius. The radius is what we're looking for, and then we have the height right here, 11. If we want to isolate for my radius, I'm going to take the 1106 and we'll divide it by the 2 pi and 11. So 2 times pi times 11, like so, and that should be equal to your radius. Okay, and just to be sure that we have our numbers right, I'm going to bring up my calculator and let's crunch these numbers in. This is a question I often see students make a mistake on, is they'll go 1106, then they'll just hit divide by and not put these different things in brackets, and your calculator will often make an error because it doesn't know what your order of operations are. Make sure you use brackets. In this case, I'll go 2 times 11 is just 22 to save myself a step, and then I'll multiply it by pi, and then we get roughly, what is that, 16.00. Now remember, we were hoping to get to the nearest centimeter, what we had right there. In this case, you look to this decimal place, it's a 0, so when you enter this thing in for this guy, it'd be r is equal to 16. So you'd have those little boxes with the decimal right here and here, and you're just going to go 16 like so. And if you want, you can fill in the positive dot like that. All right, so that concludes this section on measurement. Some of the more difficult questions, absolutely. Hopefully you enjoyed it. Thanks.